So hello guys, in this video we are going to talk about kernel density estimation, right? So it's a very basic topic whenever you try to learn Gaussian distribution and you are trying to plot CDF graph. At that time, if you have a knowledge of kernel density estimation, then you can easily learn CDF, right? Basically, kernel density, as in the CDF, in the root of the CDF we have a theory called kernel density estimation. With the help of kernel density estimation we can easily plot CDF. And if you do not watch my video on CDF and PDF, then how we can plot a CDF using NumPy, then you can see that video from I button, right? So let's check it out. The first thing, that what is the kernel density estimation here. So the kernel density estimation is provide us a density of random variable of each random variable of each random variable with the help of such non-parametric method, right? So with the help of kernel density estimation we are going to calculate the density of each random variable with the help of such non-parametric method, right? And where can we use this density function? We can use this density function in a machine learning when we are going to solve classification problem, and another problem is clustering, right? Probably you heard about this both problem. So this is all about the density, but before we move forward to implementation part, let me give you some three properties of kernel density estimation. The first density, let me give you a property right here. So I'm going to write the property. The first property is, so whatever data point you are going to plot here, that provide a normal distribution graph, right? So we can say that the first property is kernel density estimation provides that every data point follow the Gaussian distribution, right? Every data point follow the Gaussian distribution. Now we are going to talk about the second property here, the area. We are talking about the area under this particular line. So here we have a line and area, which is the part of this area would be 1. So if we try to calculate the area, then suppose here I'm going to name this density function is k of u, right? So the area would be 1, because this is the same thing that we have learned in our Gaussian distribution function. In a Gaussian density function we have the same area when we are going to plot a Gaussian graph. Now we are going to talk about our third property, and in the third property, when we are going to calculate the kernel density estimation, the value we will get from that cannot be negative. So this is all about the properties of kernel density estimation. Now we are going to try how we can plot kernel density estimation. Or before we are going to plot kernel density estimation, let me show you how actually does it look like. So here we have 6 data points, as you can see here, right? Okay, the first 3 is here and second 2 is here. So every data point have some distribution here, as you can see, and the top part, right, the middle part provides the maximum value. Right? So after calculating the kernel density function of each random variable, we are going to cumulate them, right? We are going to take the left part of it and we are going to take the maximum part of it and add another kernel density estimations Okay, another variable is kernel density estimation. So our graph gonna be like this, right? After cumulative. So if you're not familiar about the cumulative, then so let me write down an array 1 2 3 4 5. So cumulative means we are going to calculate 1 plus 2 here, 3, so 3 plus 3 here, 4 plus 5. It's gonna be like this, right? So this is the cumulative, and now we are going to our implementation part. So here I have import iris data set, as you can see here, right? And we have some columns: sepal length, sepal width, petal length, and petal width. We have some species, so do not worry about the species. And here I'm going to plot a KDE plot. As you can see here, the KDE plot I've imported from Seaborn library, and I'm going to plot a KDE on a sepal length centimeter. So as you can see here, I have generated the same graph that we have generated in ADA section on a histogram, right? Because histogram is quite similar to the KDE plot, because I told you whenever I started this video, at that time I told you that the most we can create a histogram on the basis of kernel density estimation, right? So this is all about the kernel density estimation. Thank you for watching.